Welcome everyone. In this session, we discuss about line coding. Line codes for electrical representation of the encoded binary streams produced by their individual transmitters, so as to facilitate transmission of the binary streams across the communication channel. The line codes are useful to convert a binary stream of zeros and ones into an electrical signal. In this session, the line codes are discussed: unipolar non-return to zero signaling, polar non-return to zero signaling, unipolar return to zero signaling, bipolar return to zero signaling, and Manchester code. Another name, split phase signaling. Now discuss about unipolar non-return to zero signaling. In this line code, a binary bit of 1 is represented by a pulse of amplitude A for the duration of the symbol. The duration of the symbol is capital T suffix B, and symbol 0 in the binary stream is always represented by a switching of pulse, that is 0. It is shown as in the figure below. The unipolar non-return to zero line code is also referred to as on-off signaling because the 0 is having the amplitude 0 and binary bit 1 is having the amplitude A, as shown in the figure. You can observe here the 0 binary bit is represented as amplitude 0 for the duration of pulse width, that is TB, and 1, all ones are represented by a signal of amplitude A. The disadvantage of on-off signaling, that is a unipolar NRZ signaling, are the waste of power due to the transmitted DC level and the fact that the power spectrum, which is shown in figure 1.6a of the transmitted signal, does not approach 0 at 0 frequency. So here at 0 frequency it is not going to approach, it is having 0.5 normalized power. Next line code, that is polar NRZ. Here symbols 1 and 0 in the binary stream are represented by transmitting pulses of amplitudes plus A and minus A respectively. Plus A is used to represent binary bit 1, minus A is used to represent a binary bit 0, as shown in the figure 1.5b. You can observe here the 0, it is having the amplitude by minus E, and 1, all ones are represented by the amplitude plus E. Here also the signal is not going to have the normalized power density 0 at 0 frequencies. The third line coding, unipolar return to zero signaling. Here, symbol 1 is represented by a rectangular pulse of amplitude A and half symbol width, and symbol 0 is represented by no pulse or the zero amplitude. It means the symbol 0 in the binary stream is always represented by a zero amplitude pulse, and the symbol 1 is having amplitude A only for the duration of half of the width of the symbol pulse. So as we can observe in the figure 1.5c, here is the representation of 0 with 0 amplitude, and 1 is having TB by 2 width. It is having TB by 2 width of plus A, and remaining half of the pulse width is 0. Hence, we are going to talk about it is a rectangular pulse of amplitude A and half symbol width. The power spectrum of the transmitted signal is as shown in figure 1.6, which is having the amplitude power spectral density at 0 frequency is about 0.25. Move towards next line coding, that is bipolar return to zero signaling. The concept of non-return to zero and return to zero is, in non-return to zero, the amplitude of the bit, it never comes to zero in the middle of the pulse width, but in return to zero, at the middle of the pulse width, the signal is coming back to zero amplitude, hence the name is return to zero. So in this bipolar return to zero signaling, it uses three amplitude levels as it is shown in the figure 1.5d. The positive and negative pulses of equal amplitudes, that is plus A and minus A, are used alternately for symbol 1, with each pulse having a half symbol width. No pulse is always used for symbol 0, means the symbol 0 is always represented by 0 amplitude, and 1 is always represented by plus A and minus A amplitude for alternative ones. As you can observe in the figure, the 0 amplitude, the 0 bit is represented by 0 amplitude. Now if you go for the 1 bit 1, for first case it is represented by plus A, but the next one is represented by, instead of plus A, it is represented by minus A. Next, similarly, the next appearing one is a violence, we are going to call this, it is going to violate the previous bit by minus A by plus A. Similarly, the last one is used for, instead of plus, the previous one is plus A, the next one is represented by minus E. The power spectra is having, the advantage of this one is it is having the power density 0 at 0 frequencies. So the bipolar return to zero line code is also called alternate mark inversion AMI signaling. Move towards the last line coding, that is Manchester code, split phase code. In this method, the symbol 1 is represented by a positive pulse of amplitude A followed by a negative pulse of amplitude minus A, with both pulses being half symbol width. For symbol 0, the polarities of these two pulses are reversed. Means the pulse 1 is reverse of pulse 0, or pulse 0 is just reverse of pulse 1. So a unique property of this Manchester code is that it suppresses the DC component and has relatively insignificant low frequency component regardless of the signal statistics. So it is used for some of the applications. Now if you go for coding of a given binary data 0 double 1 0 double 1 0 1 double 0 1, how to code this one using Manchester code? As it is explained, the bit 0, it is always having half width, half symbol width minus A, and the remaining half, the half width is minus A, and the next remaining half width is plus A. Similarly, the bit 1, it is reverse of bit 0, that is the first half it is covered by plus A and next half is covered by minus A amplitudes. Hence we are going to observe the alternating amplitudes. There is no zero amplitude in this Manchester coding. So here we are discussed the 5 line coding methods. Those are unipolar, polar, unipolar, bipolar, and Manchester. So here we are going to end this session for line codes. In the next session, we come with some more line coding concepts to convert a binary stream into an electrical signal. Thank you.